Hey everybody, welcome back here to the Stats Bunker. We are going to continue moving on with the course, and what we're doing now is Module 5, Z-scores. So the last couple of modules we've learned about a couple of families of descriptive statistics. We've got central tendency, which again, we talk about the mean. The purpose is to find the middle of the distribution, the center of it, and our measures of variability, the variance and the standard deviation, which are designed to measure the spread of that distribution, those distributions we're interested in. Now what we're going to be doing is starting to snap these puzzle pieces together and start to figure out exactly how we can put this stuff to work for us. So how we can leverage just a little bit of information, those key descriptive statistics, into some really powerful and precise conclusions. So this is when we start to fit everything together into this framework that we call hypothesis testing, these tests of statistical significance. So let's say that we have calculated a mean, we've calculated a standard deviation. Those are useful by themselves, but we can combine them to start to represent an idea called relative standing. So we've talked a little bit about relative standing in previous modules, but you've seen measures of relative standing before out in the wild. The most common one is just seeing a percentile. Like you take a standardized test, they tell you what percentage of people you scored higher than. So that's a measure of relative standing. It's not just what is your score, it's where do you fall in an entire distribution of people, every person that took this standardized test. So relative standing is basically a way of representing in a standardized way where scores fall in distributions, not just what the actual number is, but what proportion of the population is it above or below. We also can use relative standing because it's standardized to compare scores on totally different distributions to each other on a level playing field. So here's one of the tricks about relative standing. That percentile we mentioned on that standardized test. The way they calculated that percentile, they had every single score on that test. They looked at the exact number that were above you, the exact number that were below you, and just basically divided. However, with just a little bit of information about a population, we can calculate percentiles without necessarily needing every individual score. Here's how that works. So, the first piece of the puzzle, how do we represent relative standing? So let's say that we have a situation where we want to compare two different distributions, two different ways of representing the same variable. So in this case, pretty common situation. Somebody and their friend are both taking the same course, but they're taking it with different instructors. So let's say that both Sarah and Nick have taken the first exam in their stats sections, and Sarah received a score of 88, Nick got a score of 42. So raw score, Sarah's a whole lot higher. However, Sarah's exam was worth more points, right? You need to account for that. It's worth 100 points. In Nick's class, there's only a maximum of 50 points, so we need to convert a little bit there. So we could standardize that by representing them as a percentage, and if we did that, we'd say, okay, yeah, Sarah did better than Nick. Sarah got an 88% of the possible points, Nick got 84%. However, we can also factor in things like the idea that Sarah's section, section 1, had a higher average overall than section 2. Section 2's test looks like it's a little bit harder. It has a 70% average compared to the 80% in section 1. So even though Sarah did better in terms of a raw number and in terms of a percentage, we might be interested in figuring out who did better relative to their class. So that's the idea of relative standing. Where did these two students fall in their classes' distributions? To do that, again, we need a common basis of comparison. We need some way of standardizing things so that we can compare them on a level playing field, because again, they're worth different numbers of points. They have different levels of variability, as you see here from our standard deviations. So notice how little information we have. The only things we know about these distributions, this set of class scores, is one individual score in each group and two descriptive statistics, the mean and the standard deviation. The power of relative standing is that that's enough information to make some pretty precise conclusions about where these students fell relative to the rest of their class. So again, the way that we do this is by converting that information into what's called a z-score. So here's what a z-score is, and then we'll pick things up and talk about how to calculate them. But the z-score just involves taking your mean and your standard deviation, taking an individual score that you're interested in. You represent that z-score, you represent that individual score in terms of the number of standard deviations away from the mean that it is. So basically, a score could be 1 standard deviation above average. That would get a z-score of +1. It could be 2 standard deviations below average for the class. That would have a z-score of -2. So the z-score is just how many standard deviations from the mean is this individual score. Here's our formula. We see again some symbols that we've seen before here. We haven't seen the z-score before, but we've seen x, just take an individual score. We subtract the sample mean from that. Pause for a second. We've seen this formula by itself, this x minus m before. What did we call that? That was called a deviation. Remember, that was really prominent when we talked about variability. So here again, we see a deviation score in our numerator, and it's just divided by our standard deviation. So how many points from average is this individual score? And we give it context. We standardize it by dividing by the standard deviation. So you wind up with a number that tells you how many standard deviations from the mean is this individual score and in which direction. All right, that's it for now. We're going to pick things up next time and go through some examples of calculating z-scores and using them to represent relative standing. See you there.